Jembe, how are you all? I hope you all are good. And my name is Prince Nandra. I am a PhD scholar in the Department of Chemical Engineering at the Indian Institute of Technology, Ropar. So in today's lecture, we are going to understand one numerical example based on the rate of formation and the rate of disappearance, right? So let's begin the learning. So here we have question. So let's say the topic is rate of disappearance and rate of formation, right? So question is chloral is being consumed at a rate of 10 moles per second per meter cube when reacting with the chlorobenzene to form DDT and water in the reaction described below. So we have been given the reaction. So where chloral with 1 mole of chloral will react with the 2 moles of chlorobenzene to form 1 mole of DDT, 1 mole of DDT and 1 mole of water, right? So this reaction can be simplified into, we can write likewise, 1 mole of A reacting with 2 moles of B will give 1 mole of C and 1 mole of D, right? So here in the question they are asking to write the rate of disappearance and formation, which means generation. So unit are moles per meter cube per second for each species in the reaction when the rate of the reaction of chloral A R minus Ra is as 10 moles per meter cube per second, right? So here in the question they are asking to write the rate of the formation and the rate of the disappearance with respect to each and individual species, right? So how we can write? Okay, so let's say here they have also mentioned like 10 moles of reactant A will get consumed, will react with B and will get converted into C and D. So right. So as per the stoichiometric, we can see here. So every 1 mole of A will react with every 2 moles of B. Right. So A and B are reactants. So A and B will react with each other and they will get converted into C and D, right? So for every 1 mole of A, it will react with every 2 moles of B and will get converted into 1 mole of C and 1 mole of D. The C and D are the products. So products which will form during the progress of the reaction, right? So here, as per the question, we need to write the rate of the disappearance and rate of the formation for each and individual species, right? So let's write the rate of the reaction for species A, right? So here species A is chloral. So A species is chloral A, right? So rate of the disappearance of A will be minus Ra is 10 moles per meter cube per second, right? So let's say in question they have already mentioned the rate of the reaction A, Ra is 10 minus 10, right? Moles per meter cube per second, right? So which means the Ra is equal to minus 10 moles per meter cube per second, right? So let's say in order to understand, we'll make very simplified. Let's say we have the bank account, right? So in bank account, if we deposit some money in our bank account, right? So which is positive, right? So money is being formed, right? So money is being formed, right? So deposit rate is positive rate. Okay. Now let's say withdrawal rate, right? Let's say for example, if in a bank account we have 10 lakh rupees and we are withdrawing 1 lakh rupees, right, from the bank account. If someone will ask how much money you are withdrawing from your account, so what we'll say? We'll say 1 lakh rupees, right? We will never say minus 1 lakh rupees we are withdrawing from our bank account, right? So which doesn't make any sense, right? Minus 1 lakh rupees doesn't make any sense, right? So what we'll do, we'll apply the negative sign before the minus 1 lakh rupees, right? So what will happen? That will get converted into the positive sign, right? So in order to make sense the meaning of the term, right, withdrawal rate or disappearance rate, we will always say a positive numerical term, right? So for those reasons, we are writing the rate of disappearance to be a positive numerical value. So let's say, so here RJ will represent the rate of any species J, right? So if we are writing rate in terms of reactant and if we are writing the rate in terms of formation and the rate in terms of disappearance, right? So Rj will represent the rate of formation of any species J, right? And if we apply the negative sign in front of Rj, so let's say we have minus Rj, right? Rj, which means minus Rj will represent the rate of disappearance of any species J, right? So as per the question, we have minus 10 moles of A reacting with the B and getting converted into C and D. But here this Ra, which means rate of formation, right? So here we are writing the rate of disappearance, right? So we'll apply the negative sign on the both the sides. So if we apply negative sign on the both the sides, what will happen? We'll apply the negative sign on the both the side, right? So we'll have the answer as minus Ra is equal to 10 moles per meter cube per second, right? Because minus minus will get cancelled off, which means minus minus is plus, right? So minus Ra is equal to 10 moles per meter cube per second, which means minus Ra represent the rate of disappearance of A is 10 moles per meter cube per second, right? So rate of disappearance of A is 10 moles of meter cube per second, and minus the rate of and the rate of formation of A is Ra. Ra is minus 10 moles per meter cube per second. Okay, we already understand, because Ra will represent the rate of formation of species A, right? So which is minus 10 moles per meter cube per second. Okay, now let's say we are coming to the second species, which is chlorobenzene. So chlorobenzene is B, right? So B. So let's say based on the stoichiometric equation, we can understand that for every 1 mole of A will react with every 2 moles of B, right? 2 moles means twice the rate of A. Okay, so as per the question, we have 10 moles of A reacting, right? So let's say for the species B, for every moles of A that disappears, 2 moles of B also disappear, which means for every 1 mole of A, 2 moles of B will get consumed, will get interact with the A and will get converted into the product C and D, right? So let's say rate of disappearance of B is 2 minus Rb, right? Minus Rb represents the rate of disappearance of B, right? Will be 2 times that of rate of A as per the stoichiometry, right? So here we have 2 times, right? 2 times. So 1 mole of A will react with 2 moles of B. So for those reasons, we are writing the minus Rb is equal to minus 2 times of rate of the reaction of A, so which is 20, right? So let's say here minus Ra is 10 moles, so we need to just multiply with the 2, so which will get converted into 20 moles per meter cube per second. So rate of the disappearance of B is minus Rb is equal to 20 moles per meter cube per second. Okay. Now let's say the rate of the formation of B is Rb, right? So Rb will represent the rate of the formation of B, which is minus 20 moles per meter cube per second, right? Okay, see, these are the reactants, right? Now we are coming to the products. So here products we have C and D. So let's say for every 1 mole of A, every 2 moles of B will react and will get converted into 1 mole of C and 1 mole of D, right? So let's say if we make the relationship between A and C, right? So every 1 mole of A reacting with B will get 1 mole of C, right? So let's say C is DDT, right? So for every mole of A which disappear during the progress of the reaction, okay, which the moles of A will get consumed during the progress of the reaction, so 1 mole of C will appear as a product, right? So rate of disappearance of C, let's say for example, first we'll write the rate of formation of C, right? So RC will represent the rate of formation of C, right? So RC is minus times minus Ra, because both are same, because 1 mole of A is getting reacted, will get consumed and will get converted into 1 mole of C, right? So rate of formation of C will be equal to minus Ra, right? Will be, so minus Ra is what? Minus Ra is 10 moles per meter cube per second, right? So minus Ra is 10 moles per meter cube per second, right? So minus Ra, Ra is what? Ra is minus 10 moles per meter cube per second, right? So we are just multiplying with the negative sign, so which will get converted to Rc, right? Because for every 10 moles of A, we'll get 10 moles of C as a product. So Rc is product. So RC denotes the rate of the formation of C is 10 moles per meter cube per second, right? Okay, we have completed. Now let's say for the fourth species, which is water. So we apply the same relation to A, right? So let's say for every 1 mole of A, reacting with 2 moles of B, we will get 1 mole of C and 1 mole of D, right? So every 1 mole of A will get consumed and will produce 1 mole of D, right? So rate of formation of D is 10 moles per meter cube per second, right? Same. Okay, so 10 moles of A is getting consumed, then 10 moles of 10 moles of D are formed. Now, if we just apply the negative sign before the rate of the reaction of D, so minus RD will represent the rate of the disappearance of D. So here both the side we have to apply minus sign, so which will get converted into minus RD, right? So minus RD will represent the rate of the disappearance of D. It will be minus 10 moles per meter cube per second, right? We have understood, right? So why we are applying the negative sign and why we are not applying the negative sign, right? So what is the rate of the formation? What is the rate of the disappearance, right? So let's say we have some important notes which we have to understand, right? For the better clarification, right? So let's say for the better understanding, the sign conventions for the rate of the reactions, we are understanding these points, right? So let's say firstly we are understanding for the reactant point of view, right? So let's say if we have species J is reactant, okay, let's say species J is reactant, right? The numerical value of RJ, RJ, G means any species. So here we are discussing with respect to reactant, which is A, right? So the numerical value of Rj will be a negative number, right? Will be a negative number. Why? Because Rj is the rate of formation of J species, right? So which will be negative number. Okay, we have understood why it is negative number and why it is positive number. Okay. So let's say second point, the species J is product. Let's say we have the product species J. So here the Rj will be a positive number. Okay, the Rj here represents the rate of the formation of product C, right? So Rj will be a positive number. See here we can see Rj is the positive number, right? Rj is the positive number. Okay. Now third point, the rate of the reaction minus Ra. See, the rate of the reaction minus Ra is the rate of disappearance of reactant A and must be a positive number. See, minus Ra is 10 moles, is the positive number, right? Why we are keeping positive sign? Because we will never say the rate is minus 10 or negative number, right? As the simplest example of the bank account, we will never say we have withdrawn minus 1 lakh rupees. We will always say we have withdrawn 1 lakh rupees, right? So in order to make the positive sign, what we'll do, in order to make the positive sign, we'll just multiply with the minus sign on the both the sides, right? So therefore minus Ra will be 10, which will be a positive number, right? So the rate of the reaction of minus Ra is the rate of disappearance of reactant A, right? Reactant A and must be a positive number So see, must be a positive number, right? Now let's say the rate of disappearance of A, which means how fast my reactant A is getting consumed during the progress of the reaction in the reaction environment, right? The rate of the formation of A, which means how fast any species J is being formed, is being generated in the reaction environment, right? So Ra represents the rate of the formation, right? And minus Ra will represent the rate of the disappearance, right? So if A is disappear, Ra will be negative, right? See, if A is disappear, then Ra will be a negative sign, okay? Negative sign. Now let's say if A is forming, then Ra will be positive sign. See, positive Ra, right? A is forming, so Ra will be positive sign. And if A is disappeared, then Ra is negative sign. right? We have understood all the things, right? So let's say when we say the rate of disappearance, which means we want a positive number, right? Nobody wants to say the disappearance rate is minus 10, right? So we'll say disappearance rate minus RA is 10. Okay, so RA is equal to minus 10, right, which will get converted into plus 10, right? So the rate of disappearance of reactant A is equal to 10 moles per meter cube per second. Okay, so for product C and D, or let's say we have any products, right? So for product, the rate will be greater than 0. Why? Because during the progress of the reaction, in the reaction environment, the product will get generated. Okay, the product will get formed during the run of the reaction, right? So for those reasons, we are keeping the the rate of the products will be always greater than 0. See, rate of the product C is greater than 0 and rate of the product D is greater than 0, right? So here no extra minus sign is required, right? So for the reactant, let's say here reactant we have A and B. Okay, so during the progress of the reaction, the reactants will get interact with each other, and they will react, okay, in the reaction environment, and which will get consumed, which will get disappear and convert into the products, right? So for those reasons, the rate of the reactants will be less than 0. So RA is less than 0 and RB is less than 0. Why? Because here we have two reactants, A and B. Okay, so for both the rates of A and B will be less than 0. Okay, so they are being consumed. So RA is less than 0 and RB is less than 0, right? So to report a positive rate of disappearance, we put a minus sign in front of RA, right? So rate of the reaction A, so we just put the minus sign, so this will get converted into minus RA, right? So minus RA will be, so minus 10 we already have, and we just put the negative sign, which will get converted into the positive numerical value, right? So to report a positive rate of disappearance, we put a minus sign in front of rate RA, right? So I hope it is clear, right? I hope. Okay, so in today's lecture, we have understood the numerical example based on the topic, the rate of formation and the rate of disappearance. Okay, so this unique example will help you to clarify your doubts and to clarify your concepts based on the rate of disappearance and based on the rate of formation, right? How we are using the sign convention for the rate of disappearance and for the rate of formation for the reactants, and how we are using the sign convention for the rate of formation and for the rate of disappearance for the rate for the products, right? So I hope it is clear, right? So I request you to please make a note of all these note, right? Please make a note of all these things, okay? So which will help you for your learning and for the understanding point of view, and which will helpful for you for your exams, right? So if you have any questions or query, if you have any suggestions, feel free to comment below. Okay, I will try my best to reply to your comments. Okay, so thank you for watching, and I request you to please subscribe my YouTube channel. Please like the video. Please share this video with your friends. Okay, and until then, stay focused, stay curious, and keep learning. Okay, thank you. Jai Hind.